today we want to take a more detailed look. We want to take another stop at trigonometric functions, trigonometric built-in functions. I want you to remember that all of these functions, you can find them in the help of MATLAB. I actually have trigonometric functions, I think, open in the help right now. Okay, so this way, trigonometric function is just for you to come and type here trigonometric functions and you will find them. Okay, this is a list of trigonometric functions. As you know, you have sine, you have cos, you have tan, cotan, which is one on tangent, secant, which is one on cosines, cosecant, which is one on sine, and you have their respective inverses here, a sine, a cos, a tan. They are all here. Okay, if you select this, you will have the details of how it functions. So just come here, as I said in the previous tutorial. Whenever you see a title here, just come and type it this way if you cannot find to find it in your own help. Okay, good. That being said, let's return to MATLAB. So we've seen in the introduction that if I say sine of sine works for radian values. Okay, it works for radian angles. So if I say sine of pi on what did we look? What did we say? Is it pi on 6, right? Pi stands for 180, right? So pi on 6 will be 30. So to say we'll have 0.5. Okay. Don't worry that I'm doing this formal short J all the time. I am using the formal long for a different purpose. Okay. So just forgive that. Okay. So sine pi on 6 will have 0.5. Okay, and we said if we want it in angles, then we'll say sine d of 30, right, to give us the same 0.5. So it's very important when you're computing with MATLAB. This is an error that I've made several times, so I'm just mentioning it in passing. Don't confuse sine and sine d. Sine takes the argument in, it expects angles in radians, and sine d expects angles in degrees. This is a very, very important detail. But okay, it can also go the other way around. Okay, so if I say a sine, that is the inverse of sine for it for 0.5 rather, sorry. Okay, that gives me 0.5 to, let's try to calculate pi on 6 and see what that gives us. You see, it's the same, 0.5236, 0.5236. So a sine of 0.5 will give us the angle in what? In radians. Okay, but if I say a sine d of 0.5, then it gives me 30 degrees, and the answer is in degrees. So just to say that the normal functions, whether it is sine, whether it is cos, whether it is tan, okay, the normal functions always expect input in radians or give you the angles in radians, should in case you're using the inverses. Okay, in the case that you're using the inverses. And if you want the answers to be in degrees, in all of those functions, you just add d in front. Okay, that's all. You just add d in front of them. But the extra thing we would like to add in this tutorial is for you to see that you can compute several angles at a specific time. Okay, you can compute several angles. You remember we saw line space, right? We saw line space in one of the tutorials. In when was that? When was that? Yeah, somewhere back, right? We saw line space somewhere back. So let's say I want to create a vector, okay, that has several angles. Line space of let's say it goes from 0 to 180 degrees. Okay, let's say we want something like approximately 6 points in there. I want to take a number which can divide 180 very easily. Okay, so I'll take 7 points so that we have 6 so that it will be 180 divided by 6. Okay, good. So what would that give us exactly? We'll have 0, 30, 60, 90, 1. So that's our vector v. Okay, you remember how linspace functions. And by the way, if you don't remember, just type help win, okay, and you type linspace, all of those functions, right? If you do this, voila, what happened here? Not enough input. Okay, sorry about that. Help win lin space. Oh, sorry about that. Okay, if you say help with lean space, it takes you to the help, and it explains what lean space does, right? So lean space of x1 that generates a row vector, that lean space of that generates endpoints between x1 and x2. For n is equals to 1, lean space returns x2, right? Good. You get the point. Okay, you get the point. Okay, so that being said, we have our vector v. This is our vector v. And we want to calculate the sign of all of the values herein. We don't need to go one after the other. Just say sine d. The angles there are in radians, right? Just say sine d of v. And it will compute the sign of each of the values. So sine of 0, 0, sine of 30, 0 0.5, sine of 60, this is it, sine of 91, sine of 120, that is that, sine of 150, 0 0.5, and sine of 180, 0. And it goes exactly the same for arrays, okay? So if I say A is equal to let me go a little bit ahead of time, okay? V, okay? Forget about that. Just focus on the array A, okay? If I say sine D of A, what happens? It gives me the answers, okay, for each of the elements, okay? So all of these trigonometric functions will behave exactly the same way. They will all behave exactly the same way. They will give you the answers, elements. This is so handy. This is so useful. They will give you the answers element by element, element by element. You don't need to stress, okay? So if you have a whole set of angles and you want to calculate the sine of all of them, or you have a whole set of numbers and you want to calculate the arctangent of all of them, for example, or the cosec, just apply it. Just put them in an array and then you apply the cos function and you have all their angles at your doorpost. Okay, so briefly that was what we had to cover in this particular session. So in the next tutorial we'll talk a little bit about logarithmic function in the same light, right? In the same light. Okay, so see you in the next session.